So, first of all, the German Research Center for Artificial Intelligence sounds a little bit complicated and not very close to mechanical engineering or to production. But my part, at least, is quite close. So I'm running this Innovative Factory Systems Department. And my task in this institute is to build bridges between applied computer sciences and the application in the field of the factories. I have also a professorship at the University of Kaiserslautern, and by this I have the access to the knowledge of the university, so more the science base to the research center, and then we have this SmartFactory, which is an association, a legal association under German law, with a lot of companies being partners or members of this association, and there is an executive board. I'm the chairman of this executive board, and there are also co-chairmen from industry to make it quite clear that this is an industry, academia-driven thing which we have. So first of all, I think it's quite clear to everyone that we are living already in the internet since many years, so the internet of people is a fact today. So everyone has today these little smartphones, and you can get off anywhere in the world, in an airport, wherever you are, and you switch it on, and you are just connected to the internet, and you have access to everything around the world. Now, since about 10, 12, 15 years around, we are talking about the Internet of Things, and furthermore, we are talking about the Internet of Services in the meantime, and I think especially the Internet of Services is the part of the Internet where finally the most of the money is made. So I would think that the people offering the things for the Internet of Things are the people putting a lot of effort in it, but the money will be made by the services running on that. And these are the Googles, the Facebooks, and so forth. So everything gets smart. I think that's a fact, and you can, I think you can fully agree to that. So we have smartphones, we have smart homes. We are entering again the era of smart homes. We started already in the early 2000s, but then there was a little gap in between, but now smart homes are coming up quite quickly. We have already smart cars. So also the car is already affected by these technologies, and this is for sure that we also will have smart factories, because all these technologies will also penetrate our factories and move into them and bring us new solutions. It's very important that it's not only a technology-driven thing, so it's not only technology push, but there must also be a market pull behind it, because if there's no market, the technology will not really make it. You can wonderfully see it. Many years ago, there was already the first internet refrigerator offered by Samsung. That was 2001, 2002, I guess. And this internet refrigerator was not a success, at least not in Europe and many other areas of the world as well. This refrigerator has the advantage that it was scanning all the goods, putting into the refrigerator and getting out of the refrigerator. So if the milk is out, it can order milk. But if there is no business model behind that somebody is delivering this milk, the business model will not work. So I think this was one of the major reasons that the smart home technologies, which were quite the first, I think, were not really successful, because there were still the business models missing on this side. So now we talk about the fourth industrial revolution, called in the buzzword Industry 4.0, which is a German buzzword, and this is why the German government likes to write it as a German name and not with a Y at the end, but with IE, for example. So the first industrial revolution was around 1800, I would say, so driven by all the advantages like the steam power engine, for example, but also the first trains, and many things around this time. Mostly this revolution was taking place in Great Britain at that time. Great Britain was the most industrialized country at that time. The second revolution was around 1900 to 1920 perhaps. So there are a lot of changes within this time. So we have electrical power generation and distribution, but we also had mass production like the Ford Model T, for example, being built on a conveyor belt. So bringing prices down, bringing production up. The third industrial revolution was then around the 60s and 70s. That's the electronic revolution, where we had these electronic chips available and allowing us to set up more complex electronic systems and replacing mechanical automation and transistor-driven automation at that time. And now we are looking into the future, and we say and we assume there will be a fourth industrial revolution, and this will be driven by the internet technologies, so by networking all the elements, and this is called the smart automation era. But as I said already, we are looking into the future. So we are just assuming that there will be a fourth industrial revolution. So let's wait for another 20 years or so and then look back and say, is it really an industrial revolution? I think it is, and it will be, but as I said, we have to wait what will happen there. So if we look back again, the first computers came up around the 50s, and you may call it perhaps the 2.5 revolution at that time. So there was already the first computer installed in the companies, mostly for things like accounting, for order tracking and things like this. So at that time, there was just one big computer in one company and nothing else. Then the third industrial revolution, the electronic revolution, was bringing more and more computers into that. So the PC was invented at that time, and the PC and all the other microprocessor-based systems allowed us to make new solutions. And this was taking place mostly on the control level, so on the, let's say, the medium level of the companies. And now we are going down, and we are going down to the sensor and actor level. And so there will be the fourth industrial revolution, bringing us now hundreds and millions of computers and bringing these computers and the networks down to the lowest level so that the complete company will be connected with network technologies. And I think this will be mostly based on internet technologies. So we now talk about a lot of bytes. We started with just bytes, and now we are coming into the era of terabytes. So the big data will be coming up and will be bringing us a lot of data available, and a lot of data which we can use with very many benefits for everyone. Much more important than the computers, the smallest computers and the cheapest computers, I think, are the networks, because the most advantage will come from networking all these elements, and this is what is also available right now. We have all these wonderful networking technologies, may it be wired technologies or wireless technologies. So all these technologies have matured and they are available. And they are connected mostly to the worldwide networks, to the internet. So Industry 4.0 means linking all factory objects into a network based on internet technologies, the Internet of Things in the factory, and in consequence, all objects like machines, products, but also the humans, the human people working there are smart elements in such a production system. So I talk about objects, so I don't talk about a sensor or don't talk about a worker there. So in a more general sense, we can treat these elements as abstract objects with properties and methods, like in computer engineering, for example. And we have this network, so we can connect these abstract objects via a network, and we can set up networks of these objects and can communicate. And this is the real progress we have there. So this will change our factory world in the sense that this very static 3.0 era will be replaced by a very, very dynamic thing, the Industry 4.0 era. And so we will have more communication of all these objects. So also the products will communicate. They have RFID chips on the products. The people working there will be a part of the network and can communicate. We will have remote services, as we have already in many companies for many years already. We will have access to all this data being available via cloud systems, the cloud approach. For sure, we will have, let me just see this over here. For sure, we will extend our systems dynamically. So they are not pre-planned for 100%. Just bring a new module in, just plug it in like your printer at home, and it will run and will extend your system. We will have the app world also in the factories. The first app stores from companies are available already today, and this will now being extended very, very rapidly so that we can use apps for extending or for bringing in new functions to our technical systems, but also to the people working there. So all this will be connected in a network, so we lose actually this pyramid-style hierarchical system, and we move into a more, let's say, for me, a little bit chaotic network system, which contains domains, or which we can name by domains, because every object can now talk to any other object via the network, so we don't have this hierarchy in that sense anymore, but we have the possibility of having an open network with a lot of objects communicating to each other. And this will hopefully bring complexity down because, first of all, we will have these abstract objects, so don't think about a blue sensor from this and this company, but on the first run, just talk about an abstract object sensor which has a set of methods and properties, and you can deal with these objects for quite a long time in the engineering phase without having the exact hardware information behind. And this decouples the software engineering and control system engineering from the hardware planning, and we can parallelize these things, so make it much faster than this is be done today. We will have a stronger modularization. We will use more standards in this new world, so we have to rely on standards on all levels. And we will also integrate this wonderful lean paradigm, which we have already since more than 20 years right now. So always think about real value of your parts, and you should always have in mind whether these technologies will really help you or not, and then you should apply these technologies. So going a little bit deeper into this topic, first of all, this is a quite traditional sensor as you normally have it today. So mostly you have some cables coming out of that. This is already 20 years ago. These were 4 to 20 milliamperes, for example. Then over the last 20 years, we replaced these analog cables by just networks already, the first networks. We added a little microcontroller onto that. So finally, we had field bus messages, and this sensor was sending field bus messages into a factory-specific network at that time already. And now we are coming to the next step. Now we are adding a micro web server to this sensor, for example, or whatever this may be, to any object. So this gives us now an IP address and the IP technology. So this sensor will be now finally a part of the internet, and the communication will go also a level higher, and it will go from the messages, it will go to services. So we talk about service-oriented architectures on this level. So these elements will offer finally the self-identification. So first of all, this object may be quite unknown. Just plug it in, and it will tell the system, hey, I'm new, and I'm this and this object, for example. I'm a sensor from this manufacturer, like your printer at home when you plug it for the first time into your computer. We have a service exploration with these objects, so we can ask into the objects, what are your services which you offer into the network? And we have the active networking capability, so that these objects will automatically configure in the network, so we don't have to care about all this configuration. So this world is available today already. What you see up here, for example, this little block, this is a complete computer, a complete PC, the size of 3 pieces of cubic sugar. It costs 30 euros. There's now a new one announced which has just a factor of 1 cubic centimeter size, a complete PC with a Linux operating system on it. So the technology is available. It's cheap, it's available. So if you buy one of these things, you plug it or you implant it into your sensors for little money, you are automatically, you can be a part of the internet. So this is what we have done in our lab. So this is, for example, then here, this little block. This is a little bit of I/O and power supply, and the whole thing is now a pneumatic press, for example. So now this complete unit, the pneumatic press, is a cyber-physical system which can be linked into the internet. And actually, by this, I can sit in an airplane over the Atlantic Ocean. As long as I have the IP address, I can operate this press if I want. If this makes sense, that's a different question, but I can. So now we have built complete systems out of this. So one of these cyber-physical systems was now, we have made a complete assembly system out of this. So you see all these little PCs are running in the network, and each of these PCs is controlling one of these mechanical components. So the network of all these elements is doing the job. There is no PLC anymore. No PLC, it's just a virtualized orchestration of everything, and everything's controlled by the production information which is stored on an RFID chip on the product. So the product can tell the system what to do. We also can use these things wirelessly, so there's also a version available with an antenna on it. It's 6 or 7 euros more, and then you have a Wi-Fi connection if you want. And now, if you have these standards, then it may be a good comparison to compare it to Lego bricks, because what we have right now are standardized building blocks which we can put together as easy as playing with Lego bricks, and also rearrange the systems if we want, because it's quite easy to always link these systems together, and they will also organize by itself. So this is a picture as a comparison. So as I said, this will work only when we have standards. So we made our standards in our group of companies. We start with, we call it as a joke, that's our USB connector, but it's bigger than a USB connector, but it's nearly the same, because we have one standardized connector, and in this connector there is a power supply, 3 times 400 volts, 24 volts, emergency stop circuit, pressurized air plus network. Also, the network is also just all in one connector. Then we have the communication stack above. So we have for communication TCP/IP, the standard internet protocols. And then on the upper levels, we use OPC-UA, I think, as the only worldwide accepted client-server technology for communicating in the factory. And then it becomes quite interesting, because above communication, we will have interoperability. So we need the interoperability of these devices. A completely unknown and new robot must be able to communicate for the first time with a machine tool being in the system. So how do we set up a communication between such unknown objects? So this is interoperability, and this is the most crucial part of the job we have. So there are already a lot of standards available, but we still have to work on some of these levels, especially on the upper levels of interoperability. There's still a lot of work to be done. We demonstrated on last month's Hanover Fair that this works already in our system, but we know exactly that it's not the right time to bring it into industry. So on these upper levels, we still have to do some jobs. Unfortunately, the internet has not only advantages. The internet is cheap, it's proven, it's mature, wonderful, but also, you know, anyone can access the internet, and anyone can do some harm to these systems, as we have just learned from this French event with hacking the TV5 station, for example. So the old world is really changing in the sense that we will have now these networks. We will have more and more access to the outer world, by the internet, for example. But unfortunately, this is not the biggest danger we have, but the biggest danger is mostly coming from inside the companies, because we have USB ports, for example, but we also have people doing something which is not allowed. So most of the problems we encounter today already in the companies are not coming from the outside, but about 80% are coming from the inside of the company. So this is very important. So we have open standards, but we need the awareness that these open standards are comparable to open doors. So most of these companies have wonderful security guards outside. If they have wonderful doors, when you go in, you have to hand them over your smartphone sometimes. But in terms of the data security, they have open doors. Anyone can access this. They don't know it. That's the good message and the bad message as well. So we need technologies to solve this problem, but we also need very strict rules, what is allowed and what is not allowed, for example. So just to give you a small example, there was about 2 years ago, I think, there was a wonderful test in the US. And there was a US-based company from the aerospace and defense, so a highly secured institution, actually. And they have big fences around. And then there was a newspaper, a magazine, and they made a little test. They took 20 or 30 USB sticks in the form of a Mickey Mouse. And during the night, they have thrown them over the fence and hoping that someone will pick up these little USB sticks and put it into the computer, which was completely not allowed. So what happened, they waited just for the messages of all these USB sticks. There was a little virus on it. There was a game on it. First of all, the user will see a game. But there was also a virus reporting to this magazine which stick was activated. And I think they have thrown over 30 sticks, and about 3 were activated. And it was strictly not allowed to do this. So this shows that the major problems come from the inside. So you have to make very strict rules what is allowed on the inside as well. Another bad news is that Industry 4.0 is not a singular technology just affecting one machine, but it's really affecting the complete life cycle. So we will install more and more an information backbone in our companies, which is mostly already existing on these parts here in the beginning. So the PLM world, so engineering, design, they have already such an information backbone. Sometimes also we have already some sort of an information backbone when we talk about logistics and customer integration, for example. But here in the middle of running the systems, we have many, many systems around. So we will have more and more the reduction to just one system, to one of these information backbones. And I think this will affect the whole company operation when we go into this new era. So let's come to the practical application. So this was now a little bit more theory. Well, in practice, we decided already 10 years ago to set up such a vision in reality in our lab. So we founded 10 years ago our SmartFactory lab in Kaiserslautern. It's located here in this building. So there we have really running factory systems. So we don't talk about these things just in theory or in software, but they are real machines running. We are the worldwide biggest and well-known independent research and demonstration center for these technologies, and also the name Industry 4.0 was coming out of our lab finally in Germany. And as I said already, we are member-driven. We are an association with members, so comparable to a football club, actually. So there are academic members down here, also European ones. This is from Spain, from Sweden, from Romania. Then we have the manufacturers as members. So this is the actual list of our members from the manufacturing side. So these companies are mostly interested because they want to produce products for this new world. So they join together to set up products. And then we have the more application-oriented side of the business. So these companies up there are mostly not producing any elements for this new world, but they want to use it. So they want to have the experiences out of this world. But again, we also need, the manufacturers need also the users, because the users have to tell what they are willing to do and what they are willing to change and for which cost, for example. So this is the group which we have. You can see big names like Cisco, IBM from the US, also a part of the so-called Big Five in the US. But we also have many small and medium-sized companies in this group, and all these are joining together to bring up systems. This is now the system which we have shown a month ago on the Hanover Fair. So here you can see it's a completely modular system. It's consisting of independent modules. Each module was built by a different manufacturer. So now these modules can be put together. They are on little wheels down there. So you just can switch off one module during the running operation. The rest will still run on. We bring one module out, bring a new one in, switch it on, and immediately it runs again. So it's a completely flexible system. We can rearrange the order of these modules as we like, also under running conditions. So we don't have to shut down the complete system. We can just switch off singular modules and then rearrange the system, and it will still run. Here on the upper side, these are our so-called infrastructure partners. So they don't supply a module, but they supply knowledge or technologies for the infrastructure. So what will this mean? For example, this is our product which we produce. Here you can see this little chip. This is the RFID chip. And the first operation is always to fill the complete production information into this chip. So this is the starting point of everything. And now this product is really controlling all these modules. So let's say there's a customer coming with an urgent order, and he says, oh, I want to have a different color. And also I want to have a little gift being put inside, a USB card or a little tool or whatever else. So now we need new modules, and these new modules are waiting. The complete system is running, as you can see here from the green dots. Now we need a scale. So this is still running. This is switched off. Now the scale is being put into operation in between. Just plug it in with our USB connector, and seconds later it's running. And we decide we still have to use a robot module. Also, just bring the robot module to it, attach it, plug it in, switch it on, and the system is running. So this is what we achieved today. This is the current status we have, that we can make plug and play on this level with mechanical elements. So let's come to the conclusion. Who will start with this? Which parts of industry may be most interested to begin with? First of all, I think all the industry which have already modularity in hardware. So this is, for example, the packaging industry. They have already these modules, so it would be quite easy for them to apply these network-based control technologies into their modules, and then they can go to a plug-and-play system also quite quickly. This is parts assembly. That's the same, electronic assembly of electronic goods, for example. I think then later will be car assembly. Cars are much bigger and more complex, and it's not so modular in car assembly, but I think they will also start, but not with complete car assembly, but they will start with little parts assembly of parts being supplied to the final assembly line. So we need a strong customization, small lot sizes, a required agility, and an existing modularity. And this will help us. If this comes together, a company would be a wonderful partner to start with these technologies and move into a new era of production. And for sure, this is based on the Internet of Things. Well, nevertheless, it's still a rocky road until we really reached the Industry 4.0 reality world. So we are today actually in research. We have the industrial demonstrators. In Hanover, there was not only the demonstrator from us, there were also a lot of other demonstrators from other companies. We will have first industrial systems, I think in about 3 to 5 years perhaps, real running productive systems. On the long run, the broad industrial application, I think this will take another 10 years perhaps. So we have not a very short revolution within a couple of days, but it will be a really evolutionary development into a new world. We still need to work on the worldwide standards because remember this picture of these Lego bricks. You must achieve something like a Lego brick which is standardized all over the world, which makes it quite complicated because the world has to agree on that. So there are now standardization groups around the world active in this field, but we are still in the beginning with that. We need safety and security solutions, as I said already. When the first company is going to be shut down by a competitor from somewhere in the world due to these network problems, they will immediately lay off these new technologies, for example. So we need very convincing safety and security solutions. We need also new regulations. Many of today's regulations are not the right ones for this world. For example, in food and pharma production, you have the FDA regulations, and they don't allow any dynamic changes at all. It's just a regulation, but it's valid today. So we have to change these regulations. We need education and training for this new world. The people should no longer be trained to use a 24 voltmeter or whatever else, but they have to be trained to use a network tester and to know how to set up networks, how to monitor, to test networks. And as I said, at the end, we need new business models. Coming back to this Lego brick again, the Lego brick is just a piece of plastic. That's sense. The company Lego doesn't earn money by selling plastic blocks for cents. They are earning the money because they have a system behind, and they have a lot of other things where they make the money off. So this is also what will be changing in this world, that especially the component manufacturers have to think about new business models because they will get interchangeable, and with interchangeability, they will lose perhaps their business. And now they have to look for new business models offering systems approaches or whatever else. Yeah, a short look into the world before I finish. It's started in Germany with this idea about 4 years ago. In the meantime, the German government put some money into that to further develop all these things. Austria and Switzerland are following us in Europe. Now more and more countries from Europe will also follow us. We have the US with the Industrial Internet Consortium and also the SMLC, which is comparable a little bit to our Smart Factory Association. So this is the US side, but also here in the Far East in Asia, there are big activities being started right now. So Japan is now coming with a lot of activities. Korea is doing a lot. And China put an awful lot of money into this new technology world. So we will see what will be driven forward by the Chinese, also on the basis of a lot of funding money which is available. So thank you very much. I think I'm quite on time. If you still have questions, I am open for that. And if you want to see the website somewhere around here, I think, so look for the Smart Factory and you will see what we do there. Thank you very much.